"99% of our solar system's mass is the Sun. Our star, the Sun, is so dense that it accounts for a whopping 99% of our entire solar system. That's what allows it to dominate it gravitationally. Technically, our Sun is a G-type main sequence star, which means that every second it fuses approximately 600 million tons of hydrogen to helium. This means that it also converts about 4 million tons of matter to energy as a byproduct. Being the type of star that the Sun is, it also means that when it dies, it will become a red giant and envelop the Earth and everything on it. But don't worry, that won't happen for another 5 billion years. The Apollo astronauts' footprints on the Moon will probably stay there for at least 100 million years. Since the Moon doesn't have an atmosphere, there's no wind or water to erode or wash away the Apollo astronauts' mark on the Moon. That means their footprints, rover prints, spaceship prints, and discarded materials will stay preserved on the Moon for a very long time. All of space is completely silent. Sound waves need a medium to travel through. Since there is no atmosphere in space, space will always be eerily silent. You may be asking how astronauts can talk to each other in space. Lucky for them, radio waves can travel through space. No problem there, Houston. More energy from the Sun hits Earth every hour than the planet uses in a year. You should be sad to know that solar technology produces less than 1/10 of 1% of global energy demand. This is due to several factors, including how many land is required for solar panels to capture enough energy for a population of people to use, how unreliable it is in bad weather and at night, and how expensive that technology is to install. Neutron Star can spin at rate of 600 rotations per second. Neutron stars are one of the possible evolutionary endpoints of the high-mass stars. They are born in a core-collapse supernova star explosion and subsequently rotate extremely rapidly as a consequence of their physics. Neutron star can rotate up to 60 times per second after born. Under special circumstances, this rate can increase to more than 600 times per second.
You see